Is your company sticking to on-premise servers? Why? I've been managing servers for quite some time now. At home, on-prem, in the cloud, the more I learn, the more I believe cloud is the only competitive solution today, even for sensitive industries like banking or medical. I honestly fail to see any good reason not to use the cloud anymore, at least for business. Cost-wise, security-wise, whatever-wise. What's a good reason to stick to on-prem today for new projects? To be clear, this is not some troll question. I'm curious, am I missing something? Like many others have pointed out, I'm the CTO of a moderately sized gaming community, Hypixel Minecraft, who operates about 700 rented dedicated machines to service 70k 100k concurrent players. We push about 4 petabytes/mo in egress bandwidth, something along the lines of 32 GB/s 95th percentile. The big cloud providers have repeatedly quoted us an order of magnitude more than our entire fleet's cost, just in bandwidth costs. Even if we bring our own ISPs and cross-connect to just use cloud's compute capacity, they still charge stupid high costs to egress to our carriers. Even if bandwidth were completely free, at any time scale above 1 to 2 years purchasing your own hardware, LTO-ing, or even just renting will be cheaper. Cloud is great if your workload is variable and erratic and you're unable to reasonably commit to year-plus terms, or if your team is so small that you don't have the resources to manage infrastructure yourself, but at a team size of greater than 10 your sysadmins running on bare metal will pay their own salaries in cloud savings. A few years ago I was trying to start a company and get it off the ground. We had to make decisions on our tech stack and whether we were going to use AWS and build around their infra. Our business was very data heavy and required transferring large datasets from outside to our databases. Even in our early prototypes, we realized that we couldn't scale cost effectively on AWS. I figured out that we could collocate and rent racks, install HW, hire people to maintain, etc. for way less than we could use the cloud for. I was shocked at the difference. I remember saying to my co-founder, why does anyone use AWS? You can do this on your own way cheaper. Later I worked at a FAANG and remember when Snap filed their S1 when they were going public, they disclosed that they were paying Google $5 billion and we were totally shocked at the cost compared to our own spend on significantly larger infra. I think people don't realize this is doable, and it's great to hear stories like yours showing the possibilities. Gaming company senior reliability engineer/officer here, with the same tune. We're operating thousands of servers on 3 continents, NAR, Europe, Asia, running our own game distribution network and basically doing as much as possible on-prem. Every time we're trying to play by the cloud provider rules, we're getting stung with outrageous storage and bandwidth bills. I'm pushing for in-house K8s deployment to increase hardware utilization and drive our price/performance ratio even lower, but even now we're much better financially purchasing hardware, putting it in leased racks, doing networking ourselves and going full cycle. Probably, if we would be a smaller shop, we'd outsource networking. That's it. Same here, CTO of medium-sized company. Our IT infra costs are 1/10 the cost of cloud, simply because I happen to be comfortable having on-premise machine and working on them, sometime myself. We have 24 servers in 2 locations. It's more time to set up, but maintenance is actually quite low. Off topic, awesome seeing you here. I used to be super active on Hypixel when I was in high school. I was actually number 1 on the leaderboards for one of the games for over a year. One of my first large-scale programming projects ever was creating a Hypixel mod for my guild. Years later I am now a software engineer working at Google on the YouTube algorithm. Greater than cloud is great if your workload is variable and erratic, or if you're just constantly iterating on a large product with many engineers. Those engineers' salaries almost always outweigh all of your cloud costs, and so making them productive is cost effective. Things like SNS/SQS/S3/VPC/ELB/etc. save you countless hours and often make up for the increased cloud costs with increased developer productivity. Yes. I wonder about Second Life, which is doing a cloud uplift to AWS. The parts of the system that are variable load and web-like are already on AWS. But the region servers, one CPU for each 256 square meters, are owned outright, and in a colo in Phoenix. They're obsolete machines. But they are compute-bound, with a constant load, 24/7. Even when no user is in a region, the simulated world continues to run. Uses a bit less CPU, but the physics engine is still doing 45 cycles every second, and all scripted objects are still running. Leaves fall from the trees, plants grow, animals graze, trains run, whether or not any human is watching. They think AWS will be cheaper. I hope they are right, but have doubts. Fortunately, they're doing this slowly and carefully, and if it turns out that AWS is too expensive, they should be able to move back or to elsewhere. Since what they're doing isn't even close to what AWS normally does, they're not that tied to AWS features. I remember a post here a while back from a guy running Bitcoin mining in his dorm room. One day he realized he could offer his spare cycles to grad students with high computing workloads and undercut cloud computing prices while increasing what he made far over just mining. It's very weird that we haven't fully arbitraged $/instruction to a single, low, price yet, or storage/hosting, whichever. If only there were an Uber for unused cycles or storage. Let everyone turn their unused capacity into mini AWSs with a common interface and safety and reliability guarantees. Maybe there are too many barriers, like security. I worked for a boss that pretty much demanded that we move to the cloud. I showed them the costs for the then two providers, GCP/AWS, and arrived at the exact same conclusion on server hosting alone, as bandwidth wasn't the main driver of our application. The rationale was that we'd save so much money by not having to manage the servers ourselves, but we honestly spent much more time in software deployments than managing hardware migrations and failures. Greater than cloud is great if your workload is variable and erratic. I would say also, the cloud is cheap if you can shut down or scale down services when you need it. Imho, if you are your software stack, you can use the cloud to rationalize your spending. For instance, Netflix changed their default codec some weeks ago, which made them save a lot of money in egress bandwidth, but nobody can do this. If your company runs prepackaged software, like an SAP, Manhattan, you don't have margin to shut down services when they're not needed, at least by now. Also, after a long time working in a data center, I am still ashamed how powerful bare metal has become. For less than $30,000 you can get a 1 terabyte server, without storage, with at least 40 cores. Some vendors are even offering hardware as OPEX in a pay-as-you-go setting to compete against the cloud. Disclaimer: I work for a Google Cloud partner. What I have generally seen is that storage, blob, S3, or database, is the blocker. Even if you go to K8s, the hassle to manage storage is non-trivial. And because of this singular fact, startups cannot move to on-premise. You really don't want to manage snapshots, restores, backups. Anyone can manage application servers. Greater than about 700 rented dedicated machines to service 70,000 100,000 concurrent players. Slightly off topic, but it sounds like a single machine can't handle more than 150 concurrent players. How is this so? Is Hypixel Minecraft that resource intensive? What's the bottleneck? It is the CPU, or RAM, or the network latency per machine, or is it something else? Greater than we push about 4 petabytes/mo in egress bandwidth. With 70,000 players, 4 petabytes, 70,000 is approximately 57 gigabytes per player per month. That divided by the number of seconds in a month, 2.628 plus 6, is 57 by 10 to the power of 9, 2.628 plus 6 equals 21.7 kilobytes. Over a month, on average, a single player consumes a bandwidth of 21.7 kilobytes per second, or about 174 kilobits per second. This is an extraordinarily low per player bandwidth consumption. At 150 players, each machine would average 26 megabits per second of network traffic. This is fairly low as well. Of course, the machines have to be capable of handling possibly much higher peak usage, but even an order of magnitude more, 260 megabits per second, is something a Raspberry Pi 4, which support full throughput gigabit Ethernet, can do. To elaborate, we've worked with many customers looking to get out of slinging metal and focus on what matters to their business most. Some have said that the revenue generated justifies the cost of, but others, and I think you'll see this more over the next decade, are looking at automated bare metal. You get the primitives of the cloud but on physical servers, and more importantly with economics closer to running your own gear. Especially if you consider TCO, power, network, ops people, etc. Disclosure, I work at Oracle Cloud on the product management side, not sales. Smile. I'd like to chat with you about this. We charge a flat rate for dedicated connections and about 95 to 97% less than AWS on egress, and are just starting to talk to people about it. It's how we picked up Zoom, and 8x8, bidirectional video has huge egress charges. Let me know if you are open to chatting. There wasn't an exec team link on your webpage to reach you directly. That is where the margins come from on AWS. They are charging 10x the cost of the hardware. Even the AWS well-architected framework says that there are always trade-offs between disaster recovery and cost. For your business, cost is more important than having your servers replicated in many time zones. What about the other services? You're running a Minecraft cluster, so you're fairly detached from what running a traditional service is like these days. Will those same sysadmins make API gateway for me? Or SNS? If you look at AWS and see only its EC2 offering, then that's part of the problem. I just moved a customer from on-prem to AWS and they were flabbergasted at the performance difference, their processors being 3 to 4 years old at this point, and changed some of their processes from running for hours to a few minutes for 0 capex. Then Therese adding capacity. Need a new server to spin up your app. BRB while I go call Dell, ETA 2 months. Very late into the discussion. One thing that bothers me a lot is server performance. Price hasn't dropped much over the last 5+ years. Memory prices over a long period has essentially been flat. The only thing that has gotten cheaper is NAND. I kind of expect of hoping to have double the core and memory of a server for the same price in 5 to 6 years' time. And this hasn't happened. It sounds like you've got a good setup going with Colo, but just as a way of illustrating some of the small providers' lower bandwidth costs, DigitalOcean gives 3 terabytes bandwidth on a $15 2 CPU/2 GBM/60 GB SSD instance. If you ran 1,350 of them, it'd cost you $20K/month and get you your 4 petabytes egress within bandwidth allowance. This is one of the valid use cases of on-prem, predictable high network bandwidth workload. This is the exception though. An average company has the exact opposite. Non-predictable, low bandwidth workloads that are different, like data warehouse versus website. Agree on the cost for a sane organization. One draw with the cloud is that not all organizations are sane, so doing the work in-house, on-prem can be more expensive in terms of money, time, and politics than outsourcing to the cloud. Thanks for all the detailed info. I find this hard to square with the evidence that the Netflixes of the world still find it worthwhile to pay AWS then. Therese, no way that they don't have the same problems you do. Care to speculate on why they prefer to pay a vendor? It seems the Dropbox story is the exception that proves the rule. I work in Livermore Computing at LLNL. We manage upwards of 30 different compute clusters, many listed here. You can read about the machine slated to hit the floor in 2022-2023 here. All the machines are highly utilized, and they have fast InfiniBand/OmniPath networks that you simply cannot get in the cloud. For our workloads on commodity x86_64/no GPU clusters, we pay 1/3 or less the cost of what you'd pay for equivalent cloud nodes, and for the really high-end systems like Sierra, with NVIDIA GPUs and Power 9s, we pay far less than that over the life of the machine. The way machines are procured here is different from what smaller shops might be used to. For example, the El Capitan machine mentioned above was procured via the Coral 2 collaboration with two other national labs, ANL and ORNL. We write a 100+ page statement of work describing what the machine must do, and we release a set of benchmarks characterizing our workload. Vendors submit proposals for how they could meet our requirements, along with performance numbers and test results for the benchmarks. Then we pick the best proposal. We do something similar with LANL and SNL for the so-called commodity clusters, see for the latest one. As part of these processes, we learn a lot about what vendors are planning to offer 5 years out, so we're not picking off the shelf stuff, we're getting large volumes of the latest hardware. In addition to the cost savings from running on-prem, it's our job to stay on the bleeding edge, and I'm not sure how we would do that without working with vendors through these procurements and running our own systems. I interned at LLNL on 3 separate occasions during school. Everything about what you'll do in high-performance computing is levels beyond anything I've gone on to see in the real world. I cannot drop enough praise. In many similar contexts, buying hardware is different than buying services, for example, AWS time, in terms of how you interact with funding agencies. Because of those realities, you might sometimes be unable to go cloud even if it's actually cheaper. Also, licensing can be a big problem. Some software packages understand licensing for a real cluster, but have no concept of how to license for the cloud. Finally, think about all of your interactions over the last 10 years with companies behind the major cloud services. Which of them would you really trust, if it's your money/job/reputation on the line? I'm a former LLNL Lattice QCD postdoc and current user of the LLNL machines, and others. I have to say, I was wildly spoiled. Every other computing center where I have an account cannot hold a candle to the helpfulness of the LLNL support, the ease of use, except for the 2-factor requirement, which I understand, and absolutely insane power. Greater than all, the machines are highly utilized, and they have fast InfiniBand/OmniPath networks that you simply cannot get in the cloud. It's weird that these networking technologies are not used more in plain data center settings, since networking latency and throughput has to be a significant challenge to scaling up non-trivial workloads and achieving true data center scale computing. We hear a lot about how to scale out, but that's only really feasible for relatively simple workloads where you just seek to do away with the whole issue of keeping different nodes in sync on a real-time basis, and accept the resulting compromises. In many cases, that's just not going to be enough. Greater than, it's our job to stay on the bleeding edge, and I'm not sure how we would do that without working with vendors through these procurements and running our own systems. I think this is key. Also, the fact that you guys have a land grant so your data center costs are cheaper than most. Smile? I grew up across the street from the lab on Cheryl Doctor. Now early 30s, I'm a AWS architect and software engineer at a finance company in Bozeman, Montana, but I would kill to be an engineer for pursuit of knowledge. I dream of working there someday. And I miss home. Sorry about a slightly off-topic comment. Working on a deep tech startup, with a significant segment of potential customers being national labs, I'm very interested in learning various aspects, beyond the basics, about the processes that national labs use to procure application software, not the System 1, OS distributions, monitoring etc., but rather domain-specific one, for example, scientific data management, modeling, and simulations. I have looked at relevant sections on some of the lab's websites and my initial impression is quite fuzzy. If you are familiar with this subject, I would very much appreciate if you could clarify that. If you prefer, you can reach me at Alexander Blek Google's email service.p.s. I do have connections at some national labs, but thought that you might shed some additional light on this. I'm slowly coming to the complete opposite opinion you seem to have got. I've worked almost entirely for companies that run services in various cloud infrastructures, Azure/Heroku/AWS/GCP/other. I recently started a tiny one-man dev shop in my spare time. Given my experience with cloud services, it seemed like a no-brainer to throw something up in the cloud and run with it. Except after a few months I realized I'm in an industry that's not going to see drastic and unplanned demand. I'm not selling ads, and I don't need to drive eyeballs to my site to generate revenue. So while in theory the scaling aspect of the cloud sounds nice, the reality was simple: I was overpaying for everything. I reduced costs by nearly 90% by throwing several of my old personal machines at the problem and hosting things myself. So long story short, cost. I'm happy to exchange some scaling and some uptime in favor of cutting costs. Backups are still off-site, so if my place burns I'm just out on uptime. The product supports offline, so while no one is thrilled if I lose power, my customers can still use the product. Basically, cost, cost, cost. I have sunk costs in old hardware. It's dumb to rent an asset I already own. There might well be a point when I scale into a point where the cloud makes sense. That day is not today. What's the time trade-off? I've been drawing out my plans lately for a hobby project, all 100% on AWS. Being able to spin up my entire infrastructure with Terraform, build out images with Packer, set up rules for off-site backups, ensure everything is secure to the level I want it, etc. It takes me next to no time at all. I can't imagine buying hardware, ensuring my home is set up with proper internet, configuring everything here, and then still needing off-site backups anyway. Now, keep in mind, I'm definitely coming in from a millennial point of view. My entire career was built on cloud. I've never touched hardware apart from building a computer back when I was 15 or something. I understand virtual. But being able to build up and tear down an entire setup, having it completely self-restore in minutes. Can't beat that. Napkin math has me at $50/mo, full VPC, private/public. Isolated subnets, secure NACLs and security groups, infinitely extendable block storage and flat file storage, near instant backups with syncing to a different continent, 5 servers, DNS configurations, etc. All depends what you're doing too, of course. But for me, just the trade-off of working with what I know and not needing to leave my cafe of choice, still not breaking the bank, and if I do, having instant tear down and restore. Bam! Greater than backups are still off-site, so if my place burns I'm just out on uptime. There are plenty of exceptions, but I generally find uptime is given way too much consideration for the value it gives. Most companies up to the national level generally only require about 12 hours a day of uptime from most of their software. More than that is a nice to have, but the company won't collapse if you turn off the servers overnight because no one is working anyway. Even a whole day outage of a critical system can just mean that work has to be delayed for a day and everyone has to work a bit harder the next day. Then as you move down the scale of importance, outages can be much longer before people will even notice. I've seen plenty of 5.9 style requirements put forth, but few that truly need it and even fewer that have considered the costs imposed by it. Greater than I reduced costs by nearly 90% by throwing several of my old personal machines at the problem and hosting things myself. This is what's pulling me back towards semi-static websites. Do most of the write traffic on premises and push the results to the cloud. Only part of your application that needs to be always on. If you treat the entire thing that way, it'll cost you. I've seen a couple of read-mostly applications that are so divorced from this fact that the paths that should be the cheapest are some of the most expensive, and the ones that happen at the speed of human interaction, e.g., editing things, are fast. They are in effect backward and inside out. IMHO, the optionality the cloud gives you, is the main value at the low end. You can play around with different architectures, mixing and matching managed services with no commitment. When you need to scale, you can always switch to on-prem, and with the benefit of having a working system to base your hardware requirements on. Of course, this migration has costs too, but if this is your strategy, you can minimize cloud-specific dependencies and leverage automation that can be used in both environments, e.g. Ansible. University Research Group here. Simply_cost_. Our compute servers crunch numbers and data at greater than 80% util. Our servers are optimized for the work we have. They run 24/7 picking jobs from queue. Cloud burst is often irrelevant here. They deal with terabytes or even petabytes of moving data. I'd cry paying for bandwidth costs if charged euro/GB. Sysadmin yours truly would be needed even if it were to be run in the cloud. We run our machines beyond 4 years if they are still good at purpose. We control the infra and data. So, a little more peace and self-reliance. No surprise bills because some bot pounded on a S3 dataset. Our heavy users are connected to the machines at a single hop smile, no need to go across one for work. In Germany it's a pretty common thing for universities to have some servers for themselves. Their use case is kinda different. The servers mostly run heavy CS research related stuff. For example, they might have heavy CPU load and heavy traffic between their servers, but they have less often heavy traffic to the normal internet. If they have heavy traffic to the outside, it's normally to other research institutes, which not seldom have dedicated wire connections. 2. They might run target-specific optimized CPU or GPU heavy compute tasks going on for weeks at a time. This is really expansive in the cloud, which is mostly focused in things like web services. 3. When they don't run such tasks in the research groups, they want to allow their juniors to run their research tasks for free. Which wouldn't work with a payment model as done in the cloud. 4. They don't want to relay on some external company. Also, I'm not sure are there even affordable cloud systems with compatible spec. Like with 4+ TB of RAM, I'm not kidding, this is a requirement for some kind of tasks, or they will take way too long and requires additional complexity by using special data structures which support partial offline data in the right way, which can be very costly in dev time. It's extremely common for academic research groups to have their own hardware. Often, it doesn't make sense from an overhead/maintenance point of view. If you're a single lab large enough to need dedicated compute, you often don't have the budget for a good admin. If you're part of a larger group, like it sounds like you are, it is easier and you can afford some of the extra overhead. But I've found that there are 2 reasons why there is still a lot of on-premise academic compute: 1, legal, 2, CapEx. For the first, there are still many agreements for data sharing that require strict security compliance. It is certainly possible for this to work on the cloud, but it is more difficult than setting up a hardened cluster that's not exposed to the internet. IT is normally better set up to audit and improve these on-premises systems than cloud systems. For the second, it is difficult to estimate and write in all of the cloud costs for a grant budget. Trying to manage OpEx can be more of a hassle than just budgeting X amount for servers, as a CapEx. Often, you just care about getting the job done, but less about how long it takes. So, a set capital expense has lower risk than underestimating your cloud needs, and not being able to finish your project. Also, as a bonus, Once the equipment is paid for, you get to keep it to use on the next project, or unfunded research. When I was in academia, I was stuck using the HPC facilities at my institution. I was lucky to get about 30 cores, and my jobs took many months to run to get out of the queue. Overall, I used about a decade of CPU time. I'm quite sure that 2 months of my time waiting for results, and the impact on colleagues occupying their HPC cluster, was worth the $9,000 or so it would have cost to rent enough VMs to get my results in about 4 hours or so instead of 2 months. That's not counting the hours of machine and my time wasted building enough support for the awful queuing and execution environment it used, which was almost impossible to mock up locally. Can you share the architecture stack? What form do these jobs have? How do you manage workloads? How do you manage resources? Do users have quota for compute and storage? Do you use GPUs? If so, how do you deal with malfunction? Is this a distributed processing? Are the machines heterogeneous? What do you use for that cluster? What if a job requires dependencies? Do you create a compute environment on the fly, or do all jobs have the same dependencies and these don't change much? How do you do data governance? Is the data read-only? Do you have an API to fetch the data from the job code? Meta comment cost. 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 Abilities, guarantees. Cost. Cost. Threat model. Cost. 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 That's just the in-order top comments I'm seeing right now. Please do read and upvote them, others too, they're widely varying in their details and are interesting. The answer's the same as it has always been. Cloud is more expensive, unless you're small enough to not pay for a sysadmin, or need to swing between truly extreme scale differences. And a few exceptions for other reasons. We have around 20 servers in a colo center down the street. At this number of servers we can still host websites that have millions of users, but not tens of millions. They are not exotic servers either. In fact, by now they are, on average, around 11 years old. And costed anywhere from $2K to $8K at the time of purchase. Some are as old as 19 years. Hell, when we bought some of them, with 32 gigabytes of memory each, AWS had no concept of high memory instances, and you had to completely pay out your ass for a 32 gigabyte server, despite RAM being fairly cheap at the time. We have no dedicated hardware person. Between myself and the CTO, we average maybe a day per month thinking about or managing the hardware. If we need something special set up that we have no experience in, we have a person we know that we contract, and he walks us through how and why he set it up as he did. We've used him twice in the last 13 years. The last time one of us had to visit the colocation center was months ago. The last time one of us had to go there in an emergency was years ago. It's a 5-minute drive from each of our homes. So, why exactly should we use the cloud? We have servers we already paid for. We rent 3 cabinets. I don't recall the exact cost, but I think it's around $1,000 per month. We spend practically no time managing them. In our time being hosted in a colo center, the past 19 years, we've had a total of 3 outages that were the fault of our colo center. They all lasted on the order of minutes. I think people who have no experience managing servers dramatically overestimate how much time it takes to manage servers. Depending on your team, it can definitely be easier to manage your own hardware than to manage your cloud infrastructure. Yes. Why? Cost, availability, flexibility, bandwidth. For a lot of companies, on-prem servers are the best solution for efficiency and cost. One great example. We were paying $45K/year for a hosted MS Dynamics GP solution. For $26,000 we brought it in-house with only a $4K/year maintenance fee. We bought a rack mount Dell, put on VMware, have an app VM and a DB VM. My team can handle basic maintenance. In the past 11 months we haven't had to touch that server once. We have an automated backup, pulls VMs out daily and sends them off to Backblaze. Even if we need to call our GP partner for some specialized problem, it's not $45K/year in consulting costs. We had a bunch of Azure servers for Active Directory and a few other things. When I came in 2 years ago I set up new on-prem DC VMs, and killed out absurd Azure monthly bill. We were saving money by month 3. A Meteor could take out Atlanta and the DCs, our satellite offices, would handle the load just fine until we restored from backups and we'd still save money. We've had more uptime and reliability since then too. If I have a server go down, we have staff to get on it immediately, no toll-free number to dial, no web chat to a level 1 person in India, etc. Our EMR is hosted, because that's big enough that I want to pay someone to be in control over it, and someone to blame. However, there have been many times where I'm frustrated with how they handle problems, and jumping from one EMR to another is not easy. And in the end they're all bad anyway. Sometimes I do wish we were self-hosted. The cloud is just someone else's computer. If they're running those machines more cheaply than you are, they're cutting out some cost. The question is, do you need what they're cutting? Greater than the cloud is just someone else's computer. Well, not if it's private cloud, and only partially it's hybrid cloud. Cloud is dynamic provisioning, public cloud is cloud that is also on rented hardware. Greater than if they're running those machines more cheaply than you are, they're cutting out some cost. Economies of scale are a real thing. Greater than the cloud is just someone else's computer. If they're running those machines more cheaply than you are, they're cutting out some cost. The question is, do you need what they're cutting? They're cutting overhead and getting better deals on hardware than you could ever get. Their efficiency is their profit margin. Mostly, headspace. If I run my own server, I just need to apply my existing Ubuntu sysadmin knowledge. If I use AWS, I have to learn a whole load of AWS-specific domain knowledge, starting with their utterly baffling product names. My time is more valuable than that. Also, sheer cost. Literally everyone I know in my particular part of the industry uses Hetzner boxes. For what I do, it's orders of magnitude cheaper than AWS. I agree. I remember when I learned to use Google Cloud for ML training, it took so much time to learn how to set up everything, and to go around all their gotchas. I then tried getting started with AWS, but their poor interface and unfamiliar grounds made me stick to using plain VPSs.
Hey guys, this is the Rogue YouTuber here. I recently had a big change in my life. I had a baby daughter. Here she is. If you could do me a favor and remember to hit the subscribe button and bang the bell, I'm hoping to really create a YouTube channel that really gets people excited and brings people the best, most interesting content collated from across the internet. I'm saving up to save my little girl to Carnegie Mellon Computer Science Department. So please remember to like and subscribe. See you next time.